Hello, Y10s. I have had a few emails asking me to explain some of the stages in this analysis of a skydiver, or how will I explain the acceleration. I don't get it when they're asking me whether it is positive or negative, things like that. So I thought it is easier for me to do an audio PowerPoint explaining to you the various stages in this analysis, and then you can compare it with what you have done and mark yourself. Okay, so for making the explanation easier for me, I have labeled the stages into A, B, C, D, E, and F, as you can see on the PowerPoint. And first what I did was I drew the arrows on the diagrams itself, and then I realized that there was another column basically to draw that. So I have then moved it on to the next column. So if I'm going to analyze each stage. Okay, so let's start with A. So the skydiver has just jumped from the airplane. So the first bit is draw arrows representing the weight of the skydiver and the air resistance. So the skydiver has just jumped from the airplane. So the only force acting on him is his weight. That is why you can just see one arrow down. So I have shown it as a black arrow on the left, and in the second column I have represented that using a red arrow. Then describe the acceleration. So the only force acting on the skydiver is his weight. So he will be accelerating downwards with the same acceleration as the acceleration due to gravity of the earth. So he is going downwards, acceleration is in the downward direction. So he is moving with an acceleration of 9.8 meters per second. So when the question is describe the acceleration, is it positive or negative? All you need to actually say there is it is positive. But then I have added that extra bit there of it is positive 9.8 meters per second square, or if you want you can go to 10 meters per second square, that doesn't matter. That is for you to recognize that because the only force acting on the skydiver is the weight of the skydiver, his acceleration has to be 9.8 or 10 meters per second square. And then what is happening to the velocity? Think, he's being pulled downwards. There is no other force acting on him. So if someone is pulling you in a particular direction, what will happen to you? You will be moving in that direction. Your speed in that direction would be increasing. So that's the same thing happening here. The velocity is increasing because he's being pulled downwards because of his weight. So that is the A part. The only arrow will be the weight acting downwards. The acceleration is positive, and we have given the value also 9.8 or 10 meters per second square, and his velocity increases. Now we are going to the B part. So once he starts moving, another force comes into effect. That is the air resistance trying to oppose his motion. And air resistance or frictional forces always act in the opposite direction of motion. So the weight is acting downwards, the air resistance is acting upwards. That is what you see as two arrows in the second column there. But what you have to keep in mind there is, look at the size of the arrows. The upward arrow is smaller in size than the downward arrow. So air resistance is less than the weight. So now what happens to the acceleration? Now something is pulling the skydiver in the opposite direction. Now so you have to actually calculate the resultant force acting on the skydiver will be less than what was acting before. Before it was only in stage A, the resultant force acting on the skydiver was just its weight. In B, it is the weight minus the air resistance. So the resultant force will decrease, and because of that, the acceleration will also decrease. The acceleration will not be 9.8 or 10 meters per second square anymore. But still, its value will be positive. Then what is happening to velocity? So still there is a force acting on the person. So, and he is moving in the direction of the force. So his velocity is still increasing, but the velocity will not be increasing as rapidly as it was increasing in stage A, because now there is an opposing force also. So that is about stage B. You have to show two arrows there: weight downward direction, air resistance upward direction. Length of the air resistance arrow should be less than the length of the weight arrow. Then acceleration is still positive, but it is decreasing compared to the previous value. And then velocity is still increasing, but it is not increasing at the same faster rate as it was before. Then moving on to C. Now what happens is, when the air resistance, so the speed of the skydiver is keeping on increasing, so the air resistance also keeps on increasing. And at stage C, what will happen is the air resistance becomes equal to the weight. Okay, so the air resistance acting in the upward direction becomes equal to the weight acting in the downward direction. So now there are two equal and opposite forces acting on the skydiver. So what will happen when two equal and opposite forces are acting on an object? What will be the resultant force? Resultant force will be 0. And if the resultant force is 0, resultant force is mass times acceleration. Mass is not 0. So if the resultant force is 0, that means the acceleration is 0. So whenever the forces are balanced, the acceleration is 0. Acceleration is change in velocity. So if acceleration is 0, what does it tell you about the velocity? The velocity is not changing anymore. So the velocity is constant. Okay, so that is what is happening in stage 3. So the air resistance kept increasing and it became equal. So the air resistance has become equal to the weight. Forces are balanced, so acceleration is 0, velocity becomes constant. And just an additional point there, that constant velocity is what we call, when they reach this first terminal velocity, they open the parachute. And you know, parachute means it has, once it is opened, it has a large surface area. And due to this large surface area, there is a sudden increase in the air resistance. So that is what the stage that is explained in the D part. And if you look at the arrows, you can see the upward arrow, which represents the air resistance, is now much bigger than the downward arrow, which represents the weight. So now the resultant force is in the upward direction, but the person is still moving downwards, so the acceleration becomes negative. So in previous stage, stage C, the acceleration was 0. Now the acceleration has become negative. And then whatever constant value of velocity it had before, due to the sudden increase in air resistance, the velocity decreases. Okay, so the velocity decreases. So these are the things that happens in stage D. So air resistance, due to the opening of the parachute and increase in surface area, air resistance becomes much bigger than the weight. You can clearly see that in the size difference of the two arrows there. Because of this, acceleration becomes negative because resultant force is in the opposite direction. And this sudden increase in air resistance decreases the velocity. Then we are moving on to stage E. Air resistance and velocity are always related to each other. Whenever there is a large velocity or whenever there is a large air resistance, it brings down the velocity of movement if we are moving, when we are moving in the opposite direction. And when velocity decreases, automatically the air resistance also decreases. So when in stage D, when the velocity decreased, what happened to the air resistance? Then the air resistance also automatically started to decrease. I hope you got that idea, because air resistance is something that it is a force that is resisting you, or that is stopping you from moving. So the more you try to move, more you will face the resistance. So the less you try to move, less you will face the resistance. So in part D, when the velocity decreased, then automatically the air resistance will also decrease. So then what happens in stage E is, between D and E, the velocity started to decrease, the air resistance also started to decrease, and then at E, the air resistance becomes equal to the weight for the second time. Okay? So again, the forces are balanced, they are equal and in opposite direction. So the acceleration also becomes 0 for the second time. And as said before, if the acceleration is 0, that means the velocity is not changing. So we get the second constant velocity, or the second terminal velocity. So what happens in stage E is, forces are balanced again. Size of the arrows have to be the same. Acceleration becomes 0 because the forces are balanced. Since there is no acceleration, velocity becomes constant. And then the last stage is, the skydiver has hit the ground. So hit the ground means the skydiver is not moving. So it will not have any air resistance. Again, the force acting on the skydiver is the weight, not moving. So the acceleration of movement is 0, and then since it's not moving, the velocity is also 0. Okay, so this is the answers for this particular sheet. Now if you look at the size of the arrows for all the 6 different stages, the size I have given to weight, the arrow representing weight is exactly the same, because the weight of the person doesn't change. So when I drew this on the paper, everywhere I was taking 1 centimeter as 1 centimeter to represent the weight. Then depending on the situation, either the length of the air resistance increased or decreased or became same to the weight. Okay, so I hope the worksheet is more clear now and my points make sense. If not, please feel free to email me.